Welcome back to AI Paper Podcasts. Today we're taking a deep dive into large language diffusion models. This paper introduces a really interesting alternative to the autoregressive models that are kind of dominating the large language model scene right now.
Yeah, it's a pretty cool paper. It looks at how we can use diffusion models for language tasks. It's definitely a different way of thinking about things compared to the usual approach. And the results are, they're really interesting.
Yeah, and the paper kind of starts right off the bat by acknowledging, the successes of autoregressive models, like we've seen with, LLaDA and other models. They've done some amazing things, but, they also have some limitations. What are some of the limitations that we see with autoregressive models?
Well, one of the big ones is that ARMs, they generate text sequentially, like token by token. It's kind of like, building a sentence one brick at a time. And this can be really computationally expensive, especially when you're dealing with longer sequences of text.
So, okay, if ARMs are like building with bricks, what's the analogy for diffusion models? How do they work?
That's a good question. Maybe imagine a sculptor. They start with a block of marble, right? And then they slowly chip away pieces until, they reveal this final form. So that's kind of similar to how diffusion models work. They start with a completely masked sequence of text, and then they kind of predict the missing tokens, gradually to reconstruct the original text.
Okay, yeah, that's a helpful way to visualize it. But how does that actually happen? What's guiding that scripting process?
Well, in this case, the sculpting is guided by a probabilistic model. So the model learns the statistical relationships between tokens in a huge data set, right? And then it uses that knowledge to predict the most likely tokens to fill in those gaps.
Okay. Now, I know some listeners out there might be thinking, wait a minute, isn't this just a fancy way of doing masked language modeling like we see with BERT? So how is LLaDA different?
Yeah, that's a sharp observation. It's true that masked language modeling uses similar masking techniques, but LLaDA, it takes things a step further. It optimizes what's called a likelihood bound. So essentially what that means is it's learning to generate text that closely matches the probability distribution of the original data. And this makes it like a truly generative model, It can create new text that's coherent and consistent with the training data.
So it's not just filling in the blanks, it's actually learning the underlying patterns of language itself. And that has some pretty big implications for in-context learning, right?
Yeah, exactly. Because it's a generative model, LLaDA has a real advantage when it comes to in-context learning. It can pick up on those subtle cues and relationships within a given context and use that knowledge to generate more relevant and informative responses.
Okay, that's fascinating. So now let's talk about scale. One of the big selling points of ARMs is their ability to grow to billions of parameters. Can LLaDA compete in that arena?
Yeah, that's a really important question. And the researchers actually tackled that head on. They scaled LLaDA up to a massive 8 billion parameters, which is comparable to, leading ARMs. And what's really remarkable is that it maintains strong performance even at that scale.
So no crumbling under pressure?
No, not at all. In fact, LLaDA achieved results that were on par with, or in some cases even better than, ARMs across a variety of tasks, including language understanding benchmarks like MMLU and problem-solving tests like GSMA-K.
That's really impressive. So it scales well. But how about its ability to learn from, limited data? Can it handle zero-shot or few-shot learning scenarios?
Well, actually, this is where LLaDA really shines. It showed incredible performance in zero-shot and few-shot learning tasks, even outperforming LAM2 on some benchmarks.
Wow. So even with minimal examples, it can still figure things out.
Yeah, exactly. It's it has this innate ability to grasp those underlying concepts and apply them to new situations. And when they fine-tuned LLaDA for instruction following, it excelled at tasks like multi-turn dialogue, translation, and more, which really shows its versatility and adaptability.
Multi-turn dialogue. That sounds really promising for building more engaging and interactive chatbots.
Yeah, absolutely. That ability to maintain context and coherence over longer conversations is a big step forward for diffusion models in, the field of conversational AI.
Okay, I'm pretty much sold on the potential here.
Yeah.
But every model has its weaknesses, right? Where does LLaDA struggle? What are its limitations?
Yeah, that's true. While LLaDA definitely has some advantages, it's important to remember that it's, still a relatively new approach. And the research is still going on. There's a lot more to explore and optimize.
So it's more about areas for improvement rather than outright weaknesses.
Yeah, I think that's a good way to put it. For example, the researchers experimented with different remasking strategies during inference, which is basically, how the model decides which tokens to predict at each step. And there's definitely room for like fine tuning and exploration in that area to, potentially improve LLaDA's efficiency and performance even further.
That makes sense. It's about refining the sculpting process even more. Now, I know some of our listeners are like really eager to get into the technical details here. Can you give us a quick overview of like LLaDA's architecture and, the training process?
Sure. So at its core, LLaDA uses a transformer architecture, similar to what we see in a lot of modern LLMs. But unlike autoregressive models, it doesn't use a causal mask. So that means it can consider like the entire input sequence when making predictions.
So we have a broader view of the context, which, makes sense given its ability to handle things like reversal reasoning.
Exactly. And for training, LLaDA was trained on a huge data set of like 2.3 trillion tokens, which is, comparable in scale to other large language models. They use pretty similar pre-training techniques to what we see with ARMs, but with, adaptations specific to the diffusion process.
So even though the underlying approach is different, it still benefits from those same large-scale data and computational power that have driven the success of, ARMs.
That's right. And the fact that it can achieve, comparable performance using those familiar techniques, it really says something about its potential.
All right, so I think we've covered a lot of ground here. We talked about the limitations of those autoregressive models. We've kind of delved into this fascinating world of diffusion models. We've seen how LLaDA stacks up in terms of, scalability, performance, and even those kind of unexpected strengths in areas like reversal reasoning. So what's the big takeaway here? What does all of this mean for like the future of language models?
I think the emergence of LLaDA is a really significant development. It challenges, that dominance of autoregressive models, and it presents us with a viable alternative, one that has its own unique strengths. It's not just like a cool experiment. It could really be a game changer.
Yeah, it's like we've discovered this whole new path in like the vast landscape of language models.
Exactly. And this research opens up all sorts of exciting possibilities, right? Like, can diffusion models eventually outperform ARMs in terms of efficiency and performance as they scale even further? Could we even see hybrid models that combine the strengths of both approaches?
Ooh, a hybrid model.
Yeah.
Blending the precision of ARMs with like the holistic understanding of diffusion models.
Yeah. The possibilities are really exciting. This is just the beginning of a new chapter in the LLM story.
Mm-hmm.
And personally, I can't wait to see where it goes.
I think I speak for all our listeners when I say same here. All right, everyone, that's been our deep dive into LLaDA and this fascinating world of diffusion models. Stay tuned, because in part 2, we're going to delve even deeper into the practical applications of LLaDA and explore why these advancements really matter for the future of AI.
Welcome back. We just finished exploring some of the technical marvels of LLaDA, a large language model that uses diffusion models instead of the usual autoregressive approach. So now let's kind of shift gears a little bit and talk about, the real world implications. Like, how can we actually use this stuff?
Right, because, as cool as the technical details are, what really matters is how this tech can actually solve problems, right? Like, how can it create value in the real world?
Exactly. And the potential applications for LLaDA are just massive. It's like, opening up this toolbox full of powerful new instruments.
Ooh, I love that analogy. So where do we even begin? What are some of the areas where LLaDA could really make a difference?
Well, one area that just immediately comes to mind is conversational AI. Think about things like chatbots, virtual assistants, any application where humans are interacting with machines using natural language.
Right. And honestly, a lot of those interactions can be pretty frustrating right now. It often feels like you're talking to a wall, or at least like a very simple-minded wall.
Yeah, I know what you mean. And that's because, most chatbots today are still relying on those autoregressive models. So they generate responses word by word, which can sound very robotic. They often miss those subtle nuances of human conversation.
It's like they have a really short attention span. They forget what you said 2 sentences ago.
Yeah, that's a good way to put it.
Yeah.
But with LLaDA and its ability to consider the entire context of a conversation, that could be a real game changer. We could start seeing chatbots that are much more engaging, more helpful, and frankly, less annoying to interact with.
So no more repeating yourself 5 times
Yeah.
just to get the chatbot to understand your question.
Hopefully not. And it's not just about making chatbots, more pleasant to use. It's about unlocking their true potential. Like they could become really powerful tools for communication and problem solving.
Okay, I see what you mean. So what would that look like in practice? What are some concrete examples of how LLaDA could improve those kinds of interactions?
Okay, let's take customer service as an example. Imagine a chatbot that can actually understand your problem, even if you're not explaining it perfectly. A chatbot that can remember your past interactions and offer solutions that are actually personalized.
Oh man, that would be amazing. No more like endless phone menus or getting transferred from one department to another.
Exactly. And LLaDA could also transform how we interact with information online. Like imagine a search engine that doesn't just give you a list of links, but actually understands what you're looking for and provides a synthesized answer, pulling together information from different sources.
Oh, wow. So instead of having to sift through pages and pages of search results, you get a concise, accurate response that's actually tailored to your specific query.
Right. And because LLaDA is a generative model, it could even go a step further and create new content based on your search. Think about personalized summaries of complex topics, or even, creative text formats like poems or stories inspired by your query.
That would be incredible. It's like having a personal research assistant who can not only find information, but also synthesize it and present it in a way that's both informative and engaging.
Exactly. That's the kind of potential we're talking about here. And those are just a few examples, right? The applications are really only limited by our imagination.
Okay, I'm sold. I'm officially on board the LLaDA hype train. But let's step back for a second and be a little bit realistic. There are always challenges with any new technology, right? What are some of the things we need to be mindful of as LLaDA and other diffusion models continue to evolve?
That's a really important point. As much as we get excited about the potential benefits, we can't ignore the potential risks. And one concern that always comes up with these large language models is bias. Like any machine learning model, LLaDA is only as good as the data it's trained on, right?
Right. So if the training data contains biases, those biases are going to be reflected in LLaDA's outputs.
Exactly. And that could have some really serious implications, especially in applications like, chatbots or virtual assistants where people are relying on the model's responses for important information or even making decisions.
Yeah, that makes sense. So it's really crucial to make sure that the training data is as diverse and unbiased as possible.
Absolutely. And we also need to be developing, robust techniques for detecting and mitigating bias in these models. It's an ongoing challenge, but it's one that we absolutely have to address head on.
For sure. What about explainability? With these large language models, it can be hard to understand, why the model generates a particular output.
Yeah, that's true. And this lack of explainability can be a real problem, especially in situations where we need to understand, the reasoning behind the model's decisions.
Like if a chatbot gives you a piece of medical advice, you want to know why it came to that conclusion, right?
Exactly. So as we're developing these diffusion models, we need to prioritize making them more transparent, more interpretable.
Right. It's not enough for them to be accurate. We also need to be able to trust them. And that trust comes from understanding how they work.
Absolutely. And this is an area where there's still a lot of research that needs to be done, but it's a critical part of developing these models responsibly and ethically.
Well said. Okay, so I think we've covered a lot of ground here, from the technical intricacies of LLaDA to its potential applications and even the ethical considerations, right? But before we wrap up this part, I'm curious to hear your thoughts on the bigger picture here.
Sure. What really excites me about LLaDA is that it represents a fundamental shift in how we think about language models.
Can you elaborate on that?
Well, for years, the dominant paradigm has been autoregressive models, and they've been really successful, right? But they also have limitations, and LLaDA shows us that there's another way.
A way that leverages, the power of diffusion models to really capture the complexity and richness of human language.
Exactly. And this opens up a whole new world of possibilities for how we interact with machines, how we access information, and even how we understand language itself.
It's like we've discovered this new continent in the vast landscape of artificial intelligence, and we're just starting to explore it.
Yeah, I love that analogy. This is a really exciting time to be working in this field, and I, for one, am really eager to see what the future holds.
I think I can safely say that I share that enthusiasm. LLaDA is definitely a model worth watching. It has the potential to revolutionize how we interact with language and information, and I can't wait to see what amazing applications emerge in the next few years.
Absolutely. This is a technology that could really reshape our world. And I'm confident that we're going to see some incredible advancements in the years to come.
Okay, everyone, that concludes part 2 of our deep dive into LLaDA. We've explored its potential applications, talked about those ethical considerations, and even caught a glimpse of the broader impact it could have on, the future of AI. Welcome back to the show, everyone.
So we've been on this incredible journey with LLaDA, exploring how it works, what it can do, and even thinking about the bigger picture of its impact on AI. And to kind of wrap things up, I thought it'd be awesome to bring in someone who's really on the front lines of AI research.
Absolutely. We're so excited to have Dr. Sarah Chen join us today. She's a, renowned computational linguist, the leading voice in the world of large language models. Dr. Chen, welcome to the show. Dr. Sarah Chen.
Thank you. It's a pleasure to be here.
Dr. Chen, we've been spending all this time talking about LLaDA and diffusion models. From your perspective, it's a computational linguist. What's the most exciting thing about this new approach, Dr. Sarah Chen?
Well, I think what really intrigues me is how LLaDA kind of challenges our assumptions about language modeling. For decades, it's been all about autoregressive models. They've been the dominant force. But LLaDA shows us that there's another way, right? A way that taps into the unique capabilities of diffusion models.
Right. And what are some of those unique capabilities that make LLaDA stand out, Dr. Sarah Chen? One of the key advantages is LLaDA's ability to capture what we call bidirectional dependencies in language. So essentially, you can understand how words relate to each other, not just in a linear sequence like left to right, but also in reverse. So it's not just about predicting the next word, it's about understanding that whole web of relationships between words in a sentence, right, Dr. Sarah Chen?
And this ability to understand those bidirectional dependencies has huge implications for things like machine translation, sentiment analysis, even question answering. Wow, that's fascinating. Can you give us some examples, concrete examples, of how that bidirectional understanding could actually improve those applications? Dr. Sarah Chen.
Sure. Let's take machine translation, for instance. Current systems often struggle to capture the nuances of meaning and style, especially when you're translating between languages that have very different grammatical structures.
Because they tend to translate word by word instead of considering the overall context, right? Dr. Sarah Chen. Exactly. But with LLaDA and its ability to understand those bidirectional dependencies, we could potentially develop translation systems that are more accurate, more fluent, and better able to preserve the original meaning and intent.
That would be a huge leap forward, wouldn't it? For global communication. Dr. Sarah Chen, definitely. And it's not just translation. LLaDA's bidirectional understanding could benefit other areas of natural language processing as well, like sentiment analysis. So it could help us understand not just what people are saying, but also how they're feeling, right?
Yeah.
Dr. Sarah Chen. Precisely. By picking up on those subtle cues and relationships between words, LLaDA could help us build more accurate, more nuanced sentiment analysis tools.
And those tools could be used for all sorts of things, from understanding customer feedback to monitoring social media trends.
Wow, that's incredible. So it seems like LLaDA has the potential to really change the way we interact with language and information. Dr. Sarah Chen.
I believe so, and I think as we continue to develop and refine these diffusion models, we're going to discover even more applications, things we haven't even thought of yet.
Yeah, that's the exciting part. We're really still in the early stages of exploring this new frontier, aren't we? Now, Dr. Chen, we've talked about all these potential benefits, but it's also important to be realistic about the potential risks and challenges that come with these large language models. What are some of the things we need to be really careful about as we move forward? Dr. Sarah Chen.
Well, one crucial aspect is bias, of course. As with any machine learning model, LLaDA is only as good as the data it's trained on. So if the training data contains biases, those biases are going to be reflected in the model's output. So it's really important to make sure that the training data is as diverse and as representative as possible. Dr. Sarah Chen.
Absolutely. We need to be proactive in identifying and mitigating potential biases, right?
To ensure that these models are used fairly and responsibly. Absolutely. Now, what about transparency? With these large language models, it can be hard to really understand why the model generates a particular output. So how do we address that challenge? Dr. Sarah Chen. That's a key area of research right now. We need to develop techniques for making these models more transparent, more interpretable. And that's going to involve not only understanding how they work internally, but also finding ways to explain their decisions in a way that makes sense to humans.
Right. It's not enough for these models to be accurate, right? We also have to be able to trust them. And trust comes from understanding, Dr. Sarah Chen.
Yeah.
Exactly. Trust is built on understanding. And by making these models more transparent, we can foster that trust and help ensure that they're used ethically and responsibly.
This has been such an insightful conversation, Dr. Chen. Thank you so much for sharing your expertise and your vision for the future of language models.
Yes, thank you so much for joining us. And to all of our listeners out there, thank you for tuning in to AI Paper Podcasts. We hope you enjoyed this deep dive into LLaDA and the fascinating world of diffusion models.
We'll be back soon with more explorations of cutting-edge research, so be sure to subscribe and stay tuned. Until then, keep learning, keep questioning, and keep pushing the boundaries of what's possible with AI.